Hello everyone, welcome to the section 5, Clean Architecture and Unit Test. In this section we are going to see what is clean code and why it is so important. Then we're going to talk about MVP architecture, the Model View Presenter architecture. We're going to implement the voting feature in our sample application. And finally we are going to create some unit tests. This is what we're going to learn. First, what is clean code? Then we're going to learn what is MVP architecture, and we're also going to learn how to create some unit tests. What is clean code and why it is so important? In this video we're going to learn what is clean code, the benefits of clean code, and we're also going to see some good practices of what is a good code. So what is clean code? So the creator of the language C++ states that I like my code to be elegant and efficient. Clean code does one thing well. It is very interesting that he chose the words elegant and efficient. He also says that a clean code should do one thing well. So we're going to talk about it. What does it mean to be elegant? What is efficient? And of course, why it should do one thing well. When I am writing code, I always keep in mind these 3 points. It should be readable, it should be easy to maintain, change, or extend, and it should also be testable. And why it is so important, all those points, why it is so important that we have a clean code? Because most part of the time when we are working, we are actually reading code, we are not writing code. And during the code review, which is the process when somebody else is going to review your code and make sure that you don't have any errors, if you didn't write a good code, it's going to be really difficult to do the code review. And the reason for that is because for you, it may be easier to understand your code because of course it was you who wrote it, but the reviewer itself, he doesn't really understand what is going on if you have big methods and classes, right? If you didn't pick the right names or your code is messy, it's going to be really difficult to spot errors, and of course it's going to be difficult as well to make sure that your code actually works. So this is why it's so important to create clean code, because it's going to help not only you but all the people that is going to touch, read, and maintain your code. So let's start with some real-life examples of what is clean code and what we can do to get better. See the example on the left. You have 2 variables, one called D and one called GTMSB. Of course, in the first variable you have a comment saying that it's time in days, but this is not actually a good practice because imagine that you are using this variable D along all over your code. You won't have this comment everywhere, right? So it's very important that every time when somebody reads your variable, it understands right away what it means and what it's doing, right? So on the right, you can see a good example of choosing meaningful names. So instead of choosing the D, we can choose time in days. And instead of GTMSB, we can choose generated timestamp. And something that is very important as well is make sure that you have selected pronounceable names. And the reason for that is because our brain memorizes much easier names that you can pronounce. One word for concept. So see the example on the left. You have fetch all events, and then you have get all nodes. So in both methods, you're returning a list of items. You're returning a list of event and a list of node. If you're actually doing the same action, you're returning items, you should be using the same word. So for example, fetch all events, you should use fetch all nodes or get all nodes and get all events. And the reason for that is because when you choose different words, our brain tends to think that when you're using different words, it means different things. And that could be a mistake, right? So make sure to always choose one word per concept, because this is going to help the person who is reading to better understand your code. Abstraction level. So this is a sample method that I have selected here. And in all methods, you should have only one abstraction level. So in this method here, we have two abstraction level. But first, let's understand what is an abstraction level. You may have a high abstraction level or low abstraction level. High abstraction level means that you don't really know exactly what is going on under the covers, but you have some idea. So for example, the static method from, it is actually creating a note from a text, right? So you know that a note will be created, but you don't really know how it is done. The same for the method save note. It actually save a note, and you have to pass the note, of course, but you don't really know exactly how this note is going to be saved. But in the low abstraction, you know exactly what is happening. Usually you're manipulating primitive types. So for example, when you're final text string, right? And then you're manipulating a string, you're calling the method append, which is actually modifying a primitive type string. You're appending the /n. So this is an example of low abstraction level. And it's not a good idea to mix both levels. Your method should have only one abstraction level. It should have a high abstraction level or low abstraction level, not both. And the reason for that is because it's much easier to read a method, it's much easier to understand one method when it only has one abstraction level. And we have immutability. So imagine the object person. And what is the good practice about immutability? So the immutability says that you shouldn't change your object unless you have a really good reason to do so. Imagine person, right? So why would you have a set name for that person? We don't change the names, right? It's when you change the name, you're actually creating a new person. So that's what you should do actually. So instead of changing an object, you should always try to create a new one. And the reason for that is because immutable objects are less error prone. So it's much easier to make sure that you're not making some coding mistakes or you're not changing the state of an object. So it's much easier to handle immutable objects. And then you have side effect. So imagine that you're calling a method, so for example, validate credentials, and you have to pass an email and a password, okay? So if I am calling this method validate credentials and it has two parameters, email and password, I would imagine that this method is only validating the credentials. What would happen then if inside this method I'm actually logging in a user, right? So this is one example of side effect because this is something that it is not expected. So everything that is not expected inside one method, it's called side effects and it should be avoided. Methods parameters. So it's very disappointing when you're calling a method and you have to pass a lot of methods, like dozens of methods. So it is very difficult when you have to call a method and you have to pass dozens of parameters. One way to fix that is instead of passing parameters, you could pass an object. So imagine that you have a method that you're handling the name of a person, the age, the address, and the last name. So instead of creating a method with these 4 parameters, you can only create one method that is receiving a person. And then inside the method, you could access those fields that you want, and your method would only have one parameter that it's much better than 4 parameters. And of course, the size of your classes and the size of your methods, they are very important, because when you're changing some method and it's big, it is difficult to make sure that you're not breaking someone's code, you're not changing things that you shouldn't supposed to be changing. So it is a good practice to always keep your methods with less than 20 lines. This is something that I always try to stay inside the 20 line limit. So I always try to stay inside the 20 lines limit.